Hello, my friends. Thank you very much for subscribing to our channel. As we discussed in the previous video, in a football league and in an extreme case where all the games in a season end in a draw, even the championship team will only get very few points. In theory, in a league of 20 teams playing in a home and away manner, the champion may only score 38 points. But in reality, we have never seen such a champion with 38 points, right? Then why? In fact, there is a lot of mathematics behind such a small question. We will discuss these mathematics in 2 videos. The core issue is about the probability. In short, the reason why we don't see a 38-point champion is simply because the probability of all games ending in a draw is tiny. How to calculate this probability? The first mathematical issue involved is the rule of product. The probability that if any game ending in a draw is PDN, where n is the index of the game. Because the games can basically be considered unrelated, and there are 380 games in total throughout the season, the probability PD of all games ending in a draw is simply the product of all these 380 PDN. In principle, we have no way to really calculate this result, because we have no way to really calculate each PDN. But we can roughly estimate, or even just optimistically estimate about this PD under certain assumptions. The first very optimistic estimate is that the probability of a draw in each game is as high as 99%. So how big is the product of 380 99% multiplied together? It's about 0.02. In other words, if 99 out of every 100 games are tied, it would also need about 50 seasons for one case of all 380 games ending in a draw. If the probability of each game ending a draw drops slightly from 99% to 90%, then PD drops dramatically to about 4 times 10 to the minus 18th power. That is, it needs about 2.5 times 10 to the 17th power seasons to see one case of all 380 games ending in a draw. However, 90% is still too optimistic. The following probability will be estimated a little more pessimistic than this one, but still more optimistic than the real case. Every game has 3 kinds of outcomes. Home team wins, away team wins, and a draw. Of course, the probabilities of these 3 outcomes are not the same. But if we assumed they were the same, then the probability of a draw would be 1/3. At this time, PD is about 5 times 10 to the minus 182nd power. Thus, it would need about 2 times 10 to the 181st power seasons to see a 38-point championship. If we want to characterize the probability of a draw in more detail, we can analyze it from the perspective of goals. But please note that at this point, we are still very optimistic, as we assume all the teams are the same good, and all the teams are in the same shape in any game. But only because of the luck, which isn't always the same, they may score different goals. We set the probability that each team scores m goals in a game to be PGM. Still using an idealized model that is easier to handle, we assume that PGM is proportional to alpha to the mth power. That is, a constant c multiplied by alpha to the mth power. Alpha is larger than 0 and smaller than 1. This brings us the next mathematical issue. How to find c? We add all together the PGM for m starting from 0, so as to get the probability of scoring any amount of goals, which is certainly 1. This is therefore the problem of geometric series, which we just discussed in a previous video. The result is 1 minus alpha to the mth power over 1 minus alpha. If we consider that an infinite amount of goals is also possible, that is, m can approach to infinity. Since alpha is between 0 and 1, its power of infinity will be 0. So the result becomes 1 over 1 minus alpha. Then c is its inverse, which is 1 minus alpha. Here, we want to pay special attention to PG0, which is the probability of not scoring any goal in a game, and whose value is equal to 1 minus alpha. A draw between 2 teams means that they score the same amount of goals. If there are m goals, the probability is the square of PGM, that is, the square of 1 minus alpha times the square of alpha to the mth power. Of course, m can be any integer between 0 and infinity. So this is again a geometric series with infinite elements. The final answer is the square of the difference of 1 minus alpha over the difference of 1 minus the square of alpha. By using the difference of two squares formula, we can write down the denominator as 1 plus alpha times 1 minus alpha. So the final result is 1 minus alpha over 1 plus alpha. It is the probability PDN that this game ends in a draw. Going back to the situation we discussed earlier, if PDN is equal to 99%, alpha is equal to 1 over 199. The PG0 equals 198 over 199. Which means that, of every 199 games a team plays, they cannot make any goal in an average of 198 games. If PDN is equal to 90%, alpha is equal to 1 over 19. The PG0 equals 18 over 19. Which means that, of every 19 games a team plays, they cannot make a goal in an average of 18 games. If PDN is equal to 1/3, alpha is equal to 1 second. PG0 is also equal to 1 second. Which means that, on average of every 2 games a team plays, they cannot make any goal in 1 game. This is already a terribly bad team and a terribly bad league that we can imagine in reality. If we increase alpha slightly, so that a team can make goals in 2 out of every 3 games, that is PG0 equals 1/3, alpha equals 2/3, and PDN equals 1/5. In this situation, PD is equal to 1/5 to the 380th power, which is about 2.5 times 10 to the minus 266th power. It would need about 4 times 10 to the 265th power seasons to see a 38-point championship. Even so, we still estimate this probability very optimistically, because throughout the estimation, we always assume that every team is the same good, and that they are all in the same shape of play. However, this is not the case. If we consider the teams are different, there will be some mathematics of inequalities involved, which we will continue to discuss next Friday in the 9th grade content. Thank you for watching, and see you next time.